OK, so here's how to do it. So think of each point in this space as a possible sequence of hat colors. So I'm just going to think of one color as 1 and the other color of 0. So you can think of each point here as just a sequence of zeros and ones, indicating one possible distribution. And what I'm going to do is I'm going to divide up this space according to a particular equivalence relation. So I'm going to put two sequences in the same cell, just in case they disagree only finitely. So for example, I'm going to put 0, 0, 0, 0, 0, 0 in the same cell as 1, 1, 1, and then all zeros, because they only disagree in their first 3 positions. They agree everywhere else. But I'm going to put either of those in a different cell as the sequence that just alternates ones and zeros forever, because these guys are going to disagree in all odd positions, and these guys are going to disagree in almost all odd positions, and therefore infinitely often. So all we have so far is a classification of possible sequences. So here is the strategy that our group of people can agree upon in advance. What they can do, and of course this is going to require them having superhuman powers. I mean, not unlike the power to see infinitely many hats in front of you. They are going to decide on a representative for each cell. So they're going to, as it were, they're going to name a captain. From each cell. And then the strategy is super, super, super simple. What's going to happen is that people are going to open their eyes, and they're going to be able to see almost all of the sequence. So for example, suppose that this guy says, well, I don't know what zeros hat is like, so I'm just going to write a blank, and I don't know about 1, blank, I don't know about my own blank. But from that point on, I know what the sequence is. Now notice that even though these 3 values are missing, and therefore 2 does not have enough information to determine what the actual hat distribution is, 2 does have enough information to determine which cell the actual sequence lives in. Because look, something 2 could do is just make up some values. So say just assume that those 3 are 1s, and then go to the corresponding cell, go to the cell where that sequence lives. And then, because the actual sequence will disagree at most in 3 positions from this one with the made-up 1s, so it's got to be in the same cell, because you put sequences to the same cell if they disagree only finitely. So everyone opens their eyes, and everyone knows what cell is the right one. And their strategy is just guess on the assumption that the actual sequence is the previously agreed upon representative for that cell. So you go to the cell where you know you are, and everyone had agreed and a representative from the start, and a captain for that cell. So they all agree that they're all going to answer on the assumption that that is correct. So what's going to happen? Well, this is what we know. We know that they're choosing accordance with a representative, and we know that the representative and the actual sequence are in the same cell. So we know that the representative and the actual sequence disagree only finitely. So if everyone chooses in accordance with the representative, only finitely many people are going to get it wrong, because there are only finitely many spots where the two sequences disagree. So at most, finitely many people are going to get